definition. A vector space over here, a vector space over a field, capital F, a vector space over a field, capital F, consists of a set, on which two operations, open a bracket, right, called within bracket called vector addition and scalar multiplication. Close the bracket. Or define so that for each pair of vector, xy belongs to V. For each pair of vector, xy belongs to V, comma, there is a unique element. X plus y belongs to V, and for any scalar, alpha belongs to F. For any scalar alpha belongs to F, alpha x belongs to V, such that the following axioms hold. Here only we are going to take the conditions. What are the conditions should be satisfied using addition, and what are the conditions to be satisfied using multiplication. Only if all these conditions are satisfied, it will be called as a vector space. But before going to all that one, basically two conditions should be satisfied. What are they? Vector addition and scalar multiplication. Scalar multiplication is this alpha will be any constant. Okay, wow. So when you multiply the constant by x, what should happen? It should belong to our b. Okay, நம்ம என்ன ஆபரேஷன் பண்ணாலும் நமக்கு வர ஆன்சர் என்ன எதுக்குள்ள இருக்கணும்? நம்ம டிஃபைன் பண்ற b குள்ள இருக்கணும். அப்படி இருந்தா தான் all the conditions are satisfied. அது b குள்ள இல்லனா then it is not going to be a vector space, or it is not going to be a group, or it is not going to be a field. So நம்ம டிஃபைன் பண்றத b எப்படி டிஃபைன் பண்ணோம்னா இந்த மாதிரி ஆபரேஷன்ஸ் இருக்குங்கறத நம்ம டிஃபைன் பண்ணிடணும். Okay, whatever elements you are going to take that should satisfy that condition, and the final answer also should belong to the same b. Then only it will be called as a vector space. For that we are going to take some more conditions. Before that, how will you add this vectors? What will be the answer for this vector? Vector addition is how? A comma B comma 0. How do you add it? First element to first, second one to second, and third one to third. A plus 0, 0 plus b and 0 plus 0. Everyone knows the vector addition? Yes, no, like normal addition. Okay. Then what will be the answer for this one? This is called as scalar multiplication. What will be the answer? Cx cy c. Everyone knows the vector addition and multiplication. No, we will discuss in this video. Yes, if you know this basically, that is enough. No need to go for very deep. Okay, everyone knows how to do the addition and multiplication. Yes, now take out the conditions now. So here we are going to define the vector space with two operations. One with respect to addition and another one with respect to multiplications. So for each one there are actions now. All those actions should be satisfied. In some books they may write the vector space as like this notation. So vector space space where the two binary operators, one will be addition and the other one will be multiplication. For multiplication, they may use a symbol as dot or they may use the symbol as asterisk also. Okay, so what is the meaning? Vector space with two binary operations. One is addition and another one will be multiplication. Now take all the conditions. So first one, under addition. We are going to take the conditions under addition. Under addition. So under addition, first condition, commutativity. First condition, commutativity. Commutativity. So what is the meaning of this commutativity condition is that x plus y should be equal to y plus x. X plus y should be equal to y plus x for all x, y belongs to G. Then the condition is said to be commutativity. X plus y should be equal to y plus x. Don't assume this is numbers, it is not numbers, it is the variables. The corresponding operator plus only will define what is the nature of this one. Okay, well, don't think this is an obvious one. This is not your obvious one. Okay, because it depends on the operation what you are going to define. Second one, associativity. Associativity. So right, x plus y plus z is equal to x plus y plus z for all x, y, z belongs to D. The meaning of this symbol is for all. For all. For all x, y, z belongs to D. Third one, identity. Third one, identity. Do you know what is identity, ma? Somewhere we discussed, no? What is the meaning of identity?
Addition plus 0 is x plus 0 should be
X plus 0 should be
x.
x. If you are going to operate one variable x with some other variable, the answer should be x itself. Then that second variable we call as the identity. Okay, so right, identity, there exists an element in B denoted by 0, but it is not actual 0. Use the symbol like this 0. It is called as a 0 vector. It is not 0, it is called as a 0 vector. Such that x plus 0 is equal to x for all x belongs to D. So actually that is called as 0 vector. Next one, inverse. All these four conditions under addition. Next one is called as inverse. What is the meaning of inverse, ma? We are going to add or multiply one variable with x. The resultant answer should be the identity. Then we can call the second variable as the inverse. For example, x into y should be equal to the identity element e. Here what is the identity element? 0, the 0 vector. So here x into y should be equal to 0. If we are able to find one value like this, then y is called as the inverse of x. We can say the other way also. We can say x is the inverse of y also. Okay, what should be the resultant answer for inverse? The corresponding identity element. Okay, so right, inverse for each x in B, for each x in B, comma, there exists y belongs to B such that x plus y equal to 0. X plus y equal to 0, comma, y is called as inverse of x. y is called as inverse of x. So these are the conditions should be satisfied under addition alone. How many conditions? 4. What are they? Commutativity, associativity, identity should exist, and inverse also should exist. 4 conditions under addition alone. Now we are going to take the conditions under multiplication. So right, under multiplication. Second one, under multiplication. There is one full definition mark. Second one, under multiplication. First condition, first one, alpha into x plus y should be equal to alpha x plus alpha y. Alpha into x plus y should be equal to alpha x plus alpha y. For all alpha belong to F and for all xy belongs to B. For all alpha belongs to F and all xy belongs to B. Second one, alpha plus beta into x should be equal to alpha x plus beta x for all alpha beta belongs to F and for all x belongs to B. This is based on addition. The third one will be based on multiplication. Third one, alpha into beta x should be equal to alpha beta into x. Alpha into beta x should be equal to alpha beta into x. Same one, right? For all alpha beta belongs to F and x belongs to B. For all alpha beta belongs to F and for all x belongs to B. Last one. 1 into x should be equal to x for all x belongs to B. 1 into x should be equal to x for all x belongs to B. And 1 belongs to F. 1 belongs to F field. What will be this one now? Identity. Identity means what is the logic? We multiply x with some other variable, the resultant answer should be here x itself. Then it is called as the identity. So one will be called as our multiplicative identity. What is the additive identity? 0. 0 will be the additive identity, while 1 will be the multiplicative identity. So total how many conditions are there? 4 under addition and 4 under multiplication. One if all these axioms are satisfied, we call it as a vector space. Okay, this is the third step in your algebra. Basically, we start with a group with one binary operation. Then we will extend it to the field. From field, we are extending it to the vector space. Okay, so we are like in the third stage of your linear algebra process. Another one is inclusive of the field and another one is the inclusive. Okay, we remember all the 8 conditions. What is the first condition under addition? Commutativity. Second one, associativity. Third one, identity. Fourth one, inverse. Multiplication. There are no names. What is the first condition? Alpha into x plus y should be equal to alpha x plus alpha y. Second one, alpha plus beta x should be equal to alpha x plus beta x. Third one, alpha beta into x. Fourth one, 1 into x should be equal to x. Okay, everywhere all xy will belong to the vector space V. The scalars will belong to the field V. Okay, in all the 8 axioms, that is the condition. Okay. Then what is the additive identity?
X plus 0 equal to x.
What is additive identity? 0. When it is 0? It is actually 0 vector. It is not in numerical value 0, it is a 0 vector. Okay. What is the multiplication identity? 1 is called as the multiplicative identity. Okay. So whenever you are given some conditions, check whether this set is a vector space or not. What you are supposed to do? have to check all the Z conditions. Only if all the Z conditions are satisfied, that set will be called as a vector. Otherwise, that set is not called as a vector space. Okay. Before going to the problems, take out some important theorems. Statement alone. Theorems. First one, cancellation law. First one, cancellation law for vector addition. Cancellation law for vector addition. Cancellation law for vector addition. So take down if x, y and z, if x, y and z are vectors, if x, y and z are vectors in a vector space V, such that x plus z is equal to y plus z, such that x plus z equal to y plus z, then x equal to y. This is called as the cancellation law. Okay, direct away z cancel பண்ணால x equal to y then ये cancellation law நீங்க அது எப்போ work out ஆகும்னா only it is going to be a numerical term. But here x, y, z all are what? They are vectors. Just like that you can't cancel that. Okay, so only specifically call it as a cancellation law. It can be called as a left cancellation law and it also can be called as a right cancellation law. This is called as a right cancellation law because result is in the right. So the same thing is like this. From this you are going to say that x equal to 1. Then it will be called as a left cancellation law. Just like that you can't cancel any two things in a vector. To cancel it you need this laws. Only based on this law you can cancel those vectors either in the left hand side or in the right hand side. Okay, next one, second one. The identity in B is unique. The identity in B. What is B, ma? Vector space. Always it should be written in capital B. The identity in B is unique. U-N-I-Q-E. Next one. The inverse of each element. The inverse of each element is unique. The inverse of each element is unique. So what is the difference between these two? Unique means what is the meaning? Unique means only one. Okay, that will be the only one thing. No other thing will be similar to that one. Unique means that is the meaning. That is the only one. Okay. What is the previous statement told? The identity in B is unique. Okay. The inverse of each element is unique. What is the difference between both? Yes.
There is only one.
There is only one
identity
for the entire vector space there will be only one identity. Okay, for the entire vector space there will be only one identity. But what is the meaning of the next statement? For each element there will be a unique inverse. The meaning of that one is that the entire vector space need not have a unique inverse. For each element the inverse may vary also. Okay, எல்லா செட்டுக்குமே சேர்த்து ஐடென்டிட்டி என்னவா இருக்கும்? only one. ஆனா அதே இன்வெர்ஸ் எப்படி இருக்கும்? என்டையர் செட்டுக்கு ஒரு இன்வெர்ஸ் இருக்கு. அது எப்படி இருக்கும்? For each element there will be an inverse. Okay, அந்த எலிமெண்ட்டுக்கு அந்த இன்வெர்ஸ் மட்டும் தான் யூனிக்கா இருக்கும். ஒரு எலிமெண்ட்டுக்கு ஒரு இன்வெர்ஸ் மட்டும் தான் இருக்கும். Okay, can you understand the difference between both? No? Yes? Any doubt? Take on fourth theorem. Fourth one. In any vector space V, over a field F, x into 0 equal to 0, alpha into 0 equal to 0, and the third one. So we can prove all this one by just we take the statement alone, that is enough. What is 0? 0 indicates what? Identity vector. It is not normal 0, it indicates the corresponding identity vector. So put a command, right? For all x belongs to V, for all x belongs to V, and alpha belongs to F. For all x belongs to V and alpha belongs to F. So normally how the problems will be is that it will be defined as set. Okay, we asked to check whether it is a vector space or not. So to check, what you have to do? You have to check all the 8 axioms are satisfied or not. So that is the problems we are going to deal with under this vector space definition. Okay. Take down first one. Let B be the set of, let B be the set of all positive, let B be the set of all positive real numbers, all positive real numbers, full stop. Define the vector addition, define the vector addition and the scalar multiplication as follows. So this is how we are going to define x plus y equal to xy and k into x equal to x power k. So this is the binary operation we are going to define for our x plus y equal to x into y and kx equal to x power q. So right, determine whether V is a vector space. Determine whether V is a vector space over R with respect to above operations. With respect to above operations. So here how we are defining V? Set of all positive real numbers. Okay, what are the positive real numbers? 1, 2, 3, etc. We know that, right? But for proving, we are going to generally assume it as x and y. Okay, the numbers are generally we are going to assume the variables as x, y, and z. Okay, before going to the proof, what will be the answer of two real numbers when you add one? Real numbers. When you multiply two real numbers? Real numbers. Is everyone aware of that one? No? Then only we can say that whether it belongs to V or not. Now order one is sorted. It should be like a closed one. Whenever you are going to put any operation, the result of the operation also should belong to the same vector space. Okay, so whatever operations we are going to apply, the resultant answer should also belong to what? Belong to what? Same. Here what should be? Set of all positive real numbers. Okay, so start with the solution. So what is given for you? V is equal to set of all positive real numbers. So start the solution. Let V is equal to R plus. This is the symbolic representation. So before starting with the axioms, in the definition we took two conditions now. What are the two conditions we said before axioms? Vector addition and scalar multiplication should be satisfied. Only if it is satisfied, we can check with the axioms. First you have to check that one. So what is the meaning of vector addition? You have to add two variables or vectors. So if I add x plus 1, what will be the nature of this answer? Set of all real numbers. So it will belong to R plus. Whether the first condition is satisfied or not? Yes, so vector addition is satisfied. Similarly, scalar multiplication. Alpha into x. I am going to multiply any real number by any other constant alpha. What will be the resultant answer? It will be again a real number or no? Yes or no? So again the resultant answer belongs to R plus. So the vector addition and scalar multiplication both is going to be satisfied. For example, no? 5 plus 3, what is the answer? 8. Triple 1 plus 279. Don't give the answer, no need to add. Whether it belong to R plus or no? Whether it belong to R plus or no? Yes, that is the meaning of this first condition. Okay, and x may n number of but the resultant answer will belong to what? R plus. That is the meaning we are writing in terms of notation. Okay, now is it clear? Then what is the second one? Alpha x. We are going to multiply any integer by any other number. For example, say 4. Where the resultant answer belongs to R plus? Yes, if you multiply the same with 16. Where answer R plus kuma. Okay, scalar enna venalum irukku. Okay, where the resultant answer will belong to R plus or no? Yes. So similarly, instead of 2, we say it as 100. Where the resultant answer will belong to R plus or no? Yes. So it is going to satisfy for all the x and y values. So what we are saying that these two conditions are satisfied. Is it clear now how these two conditions are satisfied? Yes. Now since these two conditions are satisfied, we are going to take all the 8 axioms. Only if all the 8 axioms are satisfied, it is called as a vector space. Okay, shall we proceed? Yes, put a subtopic under addition. Under addition. Under addition. So what is the first condition under addition? Commutativity, right? Commutativity. Commutativity, right? What is the condition to prove? What is supposed to prove? X plus y should be equal to y plus x. For all x, y belongs to B. So there is different ways to prove. You can start with LHS and you can add back the RHS. Or you find LHS separately, RHS separately and prove that both are same. Anyway you can prove it. But here plus indicates not ordinary plus mark. It indicates the operation which is given in our statement. What is the binary operation defined? X plus y answer will be equal to? What is the binary operation defined? X plus y is equal to x according to this form. Okay, and alpha into x or k into x will be equal to x power k. That is the operation you should apply for this problem since it is defined. It is not ordinary addition or not ordinary multiplication. But operation எப்படி define பண்ணிருக்காங்களோ அந்த operation வச்சு தான் இத prove பண்ணணும். Okay, ordinary plus so multiplication இது கிடையாது. This is binary operation plus and binary operation multiplication. Okay, so start with our LHS. X plus y is equal to. Okay, according to the binary definition, how do you write x plus y? X. Now we have to prove that this is equal to y plus x. How can we? Xy can be written as yxy. Can you get the reason? Xy can be written as yx. I accept, but why? Because both xy belongs to what? B. But what is B here? R is a set of all real numbers. A set of all real numbers, 2 into 3 is same as 3 into 2, right? Yes or no? So only we are saying that x into y can be written as y into x because it belongs to R plus. Okay. Again, according to binary definition, how can you write yx? According to definition, how can you write yx as y plus x? That is what you are trying to prove. What are you supposed to prove? X plus y should be equal to y plus x. In this step, you are applying a binary definition. It is equal to x square. This x into y can be written as y square y into x because x and y belongs to R plus. So xy will be equal to yx. Again, by binary operation, y into x can be written as y plus x. Where the commutative condition is satisfied or not? Yes, this is how we are going to prove each one. Okay, everywhere we will mention the reason why you are going to relate it. Okay, so right, x plus y is equal which is equal to y plus x. This is again according to our binary definition. Therefore, write that conclusion: x plus y equal to y plus x for all x y belonging to V, which is equal to R plus. Conclusion. We have proved it as well. So proof பார்க்க ஈஸியாக தான் இருக்கும். ஒவ்வொரு ஸ்டெப் என்ன லாஜிக்கல் ரீசனிங் இருக்குங்கிறது மட்டும் தான் ஐடென்டிஃபை பண்ணணும். Therefore, x plus y equal to y plus x for all x y belonging to V, which is equal to R plus. Now you should know how to solve the next one. What is the second condition? Associativity. Right, second one, associativity. Second one, associativity. So what you are supposed to prove? X plus y plus z is equal to x plus y plus z. For all x, y, z belongs to V. Here V is nothing but our R plus. The same way, commutatively solve with two variables. No, the same logic we are going to apply for three variables. Start with NHS x plus y plus z. Okay, apply the binary operation for y plus z. What is the answer? Y is what is the answer? Y is z. So x plus y is z. Okay, now again it is only two vectors like x plus y. Instead of x we are having x, but instead of y what we are having y is z. So how will you apply your binary operation? X y z. Okay, so x into y is z. Okay, this can be written as x y into z. Just by putting the value. Whether both are same or not? Okay, actually this can write as x into y z. Okay, whether x into y z will be same as x y into z or different? Same. Why? Because all x y z belongs to R plus. Because all x, y, z belongs to R plus. Since x, y, z belongs to R plus. The R plus இருக்கிறதுனால இதுக்கு ஆன்சர் மாறாது. It does not change. What is the result you are supposed to get? X plus y plus z. Now the reverse way. Apply the binary operation in the reverse way. What is x, y is equal to x plus y. Assume this is one variable x and this is as y. So how do you write it? X, y plus z. Okay, well. Now apply the definition for x into y. X into y, what is the definition? X plus y plus z. Whether it is proved or not, associativity? Yes? Easy or not, ma? Just you have to think logically whether it is going to be correct or not. That's all. What is the third one? Identity. Normally, generally we said that 0 is the additive vector. So, okay, so additive identity. Okay. In the problems, what you are supposed to do is that you have to identify the identity. Directly, you should not write 0 as the identity. In some problems, you will write. But in general problems, when you do like this one, you have to find what will be the identity. Okay, for that, you are going to assume E as the identity. You are going to apply the operation, solve it, and you are going to find what will be our E value. Okay, so right, third one, identity. Identity. You are going to find what is the identity for each for the vector space. Right? Let E be the identity. Let E be the identity. So what is the condition for identity, ma? I gave you the definition, no? X plus 0 should be equal to x. 0 is called as a 0 vector. Here what is the identity I assume? E. Then what is the condition to be satisfied? X plus E should be equal to x. So right? That is x plus E should be equal to x. Let E be the identity. That is x plus E should be equal to x. Now here target is to find what is this E. How will you find it? E and then contribute. No cancellation clause. Again, binary operation. Here everywhere we use only the binary operation. How you define x plus y? X y. Instead of y, you are having it as e. So how will you write it? X equal to x. Okay, now it is only ordinary multiplication because all x and e belongs to the R plus set of all positive real numbers. From this, what is e? 1. So what is the identity element? 1. Okay, x into e should be equal to x. X can be cancelled. Why? Because is that all x and e belongs to R plus set of all positive real numbers. So directly we can cancel it. So what is the identity for our problem under addition? 1. So right. Therefore, 1 is the identity. 1 is the identity under addition. 1 is the identity under addition. Under addition. So similarly, we have to find the inverse now. What is the condition for inverse? X plus y should be equal to 0. What is 0? Identity element. So for this problem, what should be the condition? X plus y should be equal to e. Our e is equal to 1. Using that logic, you are going to find what is our 1. Okay, so fourth one, inverse. Inverse. So right, let y be the inverse of x. Let y be the inverse of x. Then x plus y should be equal to e because y is called as the inverse. But what is e for our problem? 1. So that implies x plus y should be equal to 1. How can we solve this now? Y equal to? So you write like that. Whether plus is ordinary plus? It is a binary operation. That is what repeatedly I have written. Plus is what? The binary operation. After we solve binary definition apply பண்ணனும். இங்க இருக்க பிளஸ்ங்கிறது நார்மல் பிளஸ் கிடையாதுமா, it is a binary operation. So how you define the operation? X plus y is equal to x. So how we rewrite your LHS? Xy is equal to 1. So what is y from this equation? 1 by x. Okay, so what is the inverse of x? 1 by x. What is the inverse of z? 1 by x. Where the inverse is unique for each element of law? 1 by x is the entire week on inverse. ஏன்னா x is what will be the inverse? 1 by x. Y means what will be the inverse? 1 by z means 1 by z. This is what our theorem meant. For each element there will be a unique inverse. But what about identity? The entire set will have only one identity. Okay, so right, y equal to 1 by x. Hence, 1 by x is the inverse of x. 1 by x is the inverse of x for all x belongs to R plus. For all x belongs to R plus. You can write R plus, you can write plus b also. For all x belongs to B R plus or all x belongs to B. Whether all the 4 conditions are satisfied or not under addition? Yes. So 50% it is satisfied. What is the next one you have to check? Under multiplication. How many conditions? 4. Again all the 4 conditions should be satisfied. So right, subtopic under multiplication. Under multiplication. Under multiplication. Now we are going to do the checking under multiplication marks. You have to take the definition of the scalar multiplication to solve the problem. Okay, so far everything was only addition. So we made use of this first one. Now we are going to do the checking under multiplication. So the second definition. What is the definition? Ax is equal to x and a. Start with the first one. What is the first condition we have to prove? xy belongs to R+. So we can split them down. Now can you how we go to the RHS? Let us prove that it is equal to alpha x plus alpha y.
X into y equal to x plus x into y is equal to x plus
xy is equal to
x plus
x plus y. And then this is so you will go back to this one only. We have to prove that it is equal to alpha x plus alpha y.
then lambda alpha x into alpha y
Alpha x.
into alpha y.
I got LHS answer. I'll start with my RHS now. What is RHS? Alpha x plus alpha y. According to definition, how do you write this one?
Alpha into x
What is kx, ma'am? What is kx? X power k. So you can write this as x power alpha plus y power alpha. Can you simplify this? How can you simplify? X plus y. X plus y whole power alpha எழுத முடியுமா? முடியாது. இதுதான் ஒரு ரைட் சைடு ஆன்சர். அப்ப இத வந்து அந்த மாதிரி எழுத முடியுமா யோசிச்சு. எப்படி யோசிக்கிறது நான் சொல்றேன். ஓகே என்னோட LHS இது வந்து முடிஞ்சிருச்சு. பட் எனக்கு RHS என்ன ஆன்சர் வரணும்? x power alpha plus y power alpha ன்னு வரணும். அப்ப என்னால இத வந்து மாத்த முடியுமான்னு யோசிக்கணும். Under which operation or which logic we can find? Binary addition. Again the definition. What is x plus y is equal to x. So with the same way we can say that xy will be equal to x plus y. So again by binary addition what we can say? X power alpha plus y power alpha. Whether we got the answer or not? Yes? Yes or no? Simple. So now logic mutana write the RHS separate and then combine and check what is the logic here coming. Okay, write it. So again by definition this is equal to alpha x plus alpha y by scalar multiplication. Alpha x plus alpha y. This is for your reference, ma'am. Why we are deriving that? Why we have changed all this one? I given the reasons there. Not compulsory you have to write that one. It's only for your understanding. How we are converting from this step to this step? What are the operations we are applying? That is what we are doing. Is it clear, ma? Any doubt? Any doubt? Shall we go to the next one, second one? What is the second one you have to do? Alpha plus beta into x should be equal to alpha x plus beta x. Here we have proved the result with two vectors. Then we are going to prove the result with two scalars. Has everyone covered? See, one problem also we have not completed. We have taken only one definition and we are continuing solving only one problem. It is a clear hour. Finish? Little muggles, shall I continue? Now second one, to prove. Second one, to prove. Write the second condition everyone. Alpha plus beta start with your LHS. Start with your LHS. Alpha plus beta into x can be written as x power alpha plus beta. Take this equation number 1. Start with your RHS. What is your RHS? Alpha x plus beta x. How we write this one? X power alpha plus x power beta. How can I rewrite this to the equation 1 now? Or how can I rewrite equation 1 to the equation 2 for it? Mera matna easy.
Alpha x plus beta x. Alpha x plus beta x
Alpha x.
plus beta x.
This one now. How do I write this as alpha x plus beta x? That one you know. You can apply here binary addition. What is the binary addition? X plus y is equal to x. Okay, if you apply the definition here, what you will get? X power alpha into x power beta. Okay, by binary addition. This can be written as x power alpha into x power beta. Since the base is same, what we can do? Add this. This is equal to x power alpha plus beta. This is one way of giving the proof now. We can simplify the LHS and we can come to the RHS also. Your choice. Anyway, you have to prove that LHS is equal to RHS. But apply the definitions logically in those modes. Is it clear? So whether you have put the result or not? Yes or no? So right. Therefore, alpha plus beta into x is equal to alpha x plus beta x. That's all. We have proved the second one also. What is the third one? Alpha into beta x is equal to alpha beta x. So start with the third one. Third one. To prove alpha into beta x is equal to alpha beta into x. Try to prove it. Tell me how will it start? Alpha into beta x. LHS. How do you relate this one? Alpha into beta x is under binary operation multiplication. So how do you relate that one? X power beta. Alpha into x power beta. The ordinary multiplication is one will be solved. Okay, but here it is the binary multiplication. We apply the alpha beta or bracket put x in the because beta into x is under the binary multiplication. It is not ordinary multiplication. Okay, so you written it as alpha into x power beta. How will you prove it to the next one? So in the binary relation. Alpha into how can you write alpha plus x power beta? That is only for two vectors. Alpha is a scalar.
X per beta the whole per alpha.
How can you write like that?
Kx beta x.
Again binary multiplication. A into x is written as x power k. Okay, this is k and this is our x. So k into x can be written as x power k. So you can rewrite this term as x power beta the whole power alpha. Okay, apply here binary multiplication again. Okay, now since now everything belongs to only a set of real numbers. So this is same as x power alpha beta. Okay, now it is only real numbers. It does not belong to any operations. So you can write it as x power alpha beta. From this step, how will you go to your RHS?
Kx.
Again, what definition you are going to apply? Binary addition or multiplication? Multiplication. Because kx is equal to x power k. The reverse also true. X power k can be written as kx. So instead of k, you are writing it as alpha beta. So you can write it as alpha beta into x. Okay, and the binary operations முடியவே வரைக்கும் அந்த binary operations தான் நீ apply பண்ணணும். Once you final answer வரும்போது என்னமோ everything will belong to R. Till that difficult, I will not say that it is easy. You can understand that logic. What is the fourth one you have to prove? Multiplicative identity. What is the multiplicative identity? 1 into x should be equal to x. So right. Fourth one. To prove 1 into x is equal to x. 1 into x is equal to x. 1 into x equal to x for all x belongs to V and 1 belongs to F. Can you prove it now? It's very simple. 1 into x should be equal to x. You have to prove it. Say 1 into x equal to x power 1. This is your binary operation. So here x is equal to x power k. Okay, but what is x power 1? X. Because once you remove the binary operation, it becomes as a real number. So any number to the power 1, what is the answer? Real number. So that's all. 1 into x is equal to x. No other logic. So whether all the conditions are satisfied? Yes. So right, final conclusion. Hence, B equal to R plus is a vector space. B equal to R plus is a vector space over R. Is a vector space over R. Okay, well, that's all. We have put our problem. This is a simple 8-mark question. Now no 16 mark. Okay, simple 8-mark question. Okay, everywhere what you have to apply ma? The binary addition and multiplication, whatever you have to find. So the operation you remove பண்ணி முடிச்சதுக்கு அப்புறம் அது வந்து என்ன ஆகும்? Normal variables ஆ மாறும். அது வந்து மாறும். Okay, is it clear? Yes, any doubt in your first problem? So for one problem, how much time you are taking? More than half an hour. Yes. So you discussed only for real numbers, ma. Like this, our set may be complex numbers, or it may be matrices, or it may be set of polynomials also. So if you are given like that, you have to assume there are elements to be of that format and you have to prove it. Since it was only real numbers, we assumed it to be x1 and we have proved that result. If it is going to be a polynomial, how do you write a polynomial? Generally, how do you write a polynomial? Say, one quadratic equation.
X plus
Ax square plus bx plus c. That is a second degree polynomial. Okay, if I say that my all elements belongs to that format, நீ எடுக்கிற x5 நான் எப்படி எடுக்கணும்? இங்க வந்து real numbers இருக்கிறதுனால you assume it to be x5 and you prove the result. If I have a set வந்து set of all second degree polynomial for example. Now how should I assume my x? Ax square plus bx plus c. What should be my y? Ay square plus by plus c. இந்த elements எப்படி இருக்கும்? ஒவ்வொரு element எப்படி இருக்கும்? Polynomial. அதை வச்சு I have to prove all the same results. Okay. For example, my set is going to be a set of matrices. 2 by 2 for example. How do I write 2 by 2 matrices? General way. A, B, C. Okay. So how should I choose my elements? X will be what? 2 by 2 matrices. A1, B1, C1, B1. How should be my Y? A2, B2, C2, D2. In the மாதிரி elements are எடுத்து I have to prove all my matrices. Okay, the real numbers are இருக்கறனால நம்ம x1 x1 வச்சிருக்கோம். But அந்த செட் ஆக மாத்தும்போது நீ என்ன பண்ணனும்? You assume the variables also according to the set and you have to prove the results. Okay, we are discussing two more problems before going to the next one. One problem we will be discussing based on polynomial, one problem based on matrices. Okay, these are the major things which will be asked. And என்ன மாதிரி கொடுத்தாலும் you should assume and you should try to prove all the results in one single problem. Okay, can I get an outline of the problem, how to solve? Any doubt for anyone in this?